Oh, this is also a very interesting idea of the day. Humor in the workplace isn't about making work funny or being the funniest person in the office. It's about making work fun and getting better results. And I like to think at WPI, we try to make work fun. People are really funny, in my opinion. Okay, hide this and start this presentation. So, hello everybody, I'm Christine Tang. I've been spamming people a lot with emails and on Twitter and all the social media because that's my job. Thank you, Professor Radzicki. And please mute your microphones unless you have a question to ask. And feel free to use the chat feature, but I would need someone to monitor that today for me because I'm presenting and I can't see it. And I'm currently in my parents' bedroom because I have family from California visiting and they're still sleeping and they're sleeping in my office area. So I don't have my second monitor today. And so throughout my whole journey in life, actually, not just my PhD journey, I've always questioned this. And Professor Radzicki formally gave me this challenge. Given a problem, what methods should we use? Specifically, given a complex systems problem, what methods should we use? And CLM reminders. Today, I have different parts of my presentation. I'll talk about things we like to address in CLMs, and which are collective learning meetings. I need to learn to write out my acronyms. And I'm taking notes on this too. And then after my CLM reminders, I'll talk about my quantitative PhD journey, about the models I have built that we've used data and all the different methods I've explored in operations research, talk about myself, my background, and a little simulation background for those who are not familiar with discrete event simulation, agent-based modeling, system dynamics. And I think I also mentioned a little bit about optimization models, like the linear programming, mixed integer programming, other things like that. Famous examples are the traveling salesman problem, kidney match. Oh, I'll talk about that later. I don't need to talk about that now. And then I'll talk about my qualitative PhD journey that I do not have data for. And that's very personal. So if you do not like to listen to this type of story, please feel free to sign off. And my contact info. So for our collective learning meetings, we like to have the bottom line up front. Thank you, someone who suggested that in the colloquium that WPI hosted in spring. So I guess I can talk about that too. So each academic semester, MIT, SUNY Albany, or WPI hosts a one-day conference where PhD students, or anybody actually, we open it to professionals also, but we prefer PhD or master students doing theses to present their work in process or work in progress, whatever you prefer to use, presentation or their research. Then I personally would like people to tell me what you like and dislike about my presentation style, and specifically why. I really like to know why. And a lot of people find that annoying, but it is very important for industrial and systems engineers, or any person, in my opinion, to question why. I think that just makes you a better thinker. Then what do I want the audience to learn? My takeaways? Yeah, you can learn about me, because this is a very detailed presentation about my life and my interests. And how should I focus the audience? I want you to focus on the takeaways, the feedback I said before, the presentation styles. Oh, I'm also aware I should probably make animations so people aren't overwhelmed by all the text I have, but I also have all this information on my personal website. Under presentations, I uploaded this at 11 or before 11:59 p.m. Eastern time on Wednesday, this past Wednesday, because I don't mind. I'm very open to sharing things. And so please also feel free to ask questions at any time, but I prefer it if you ask at the end of each slide because I tend to get distracted easily. So more takeaways about this whole CLM and my story is do what makes you happy, but you have to consider what is necessary for you and your family to survive, money. That's why I am currently studying economics in a sense with Professor Redzicki. I don't have any books that I'm reading at the moment, but eventually I'll read more books about economics. But I listen to professors at WPI, Saeed and Saeed Lingarudi and others. So in a sense, I don't really need a book. Oral presentations, oral history. And yeah, hopefully you'll learn from my story so you don't burn out. And feel free to talk to me anytime because I learned this the hard way. Burnout, it's terrible. I'll talk about that later. Then also please find people you can trust and talk to, people who will support you, like I did at WPI. And I also would like to mention, I really appreciate my professors at WPI. They let me study whatever I'd like. I don't like people who hold me back, and I believe nobody should say, you should do this, you should do that. Just suggest things for people and let them think for themselves. Why should I do this? Why do I want to do this? Okay, so my quantitative PhD journey. Since 2010, focus. This is my biggest problem in life. I have trouble focusing. So I'm attempting to be a WPI lifer. For those who are not aware of that term, it's to get your bachelor's, master's, and PhD at a university, specifically at WPI. I entered WPI in fall of 2009, and I earned my bachelor's in industrial engineering in May of 2013. I minored in statistics, so that's why I know what professors in the math department, and they're very kind. I did my interactive qualifying project, which is a junior year project about a world problem, and you work with people outside of your major. And it doesn't have to be in your junior year, it's just recommended your junior year. And I did that with Professor Petrucelli, who is very good at statistics, and he has helped me a lot in my career. And I credit a lot of different professors and my family and friends for helping me, especially WPI System Dynamics. And I originally wanted to also minor in management information systems, so that's SQL and other database type stuff. But in my senior year at WPI, I was doing my capstone, before the capstone project. Professor Isa Baran, she is in mechanical engineering and manufacturing such, and she focuses on health systems actually. She was also my major qualifying project professor. Well, one of them, Professor Trapp was the other, but Professor Renata Conrad was the one to set up the project with the Veterans Affairs, and we built a discrete event simulation model for the Veterans Affairs, my team and I, a team of 4. So Professor Baran, called me into her office, and I was terrified. I didn't know what she wanted to talk to me about. She wanted to offer me a position as a PhD student with a fellowship to do whatever project I would like in an area of national need. Graduate assistance in areas of national need, GAN fellow, was my first fellowship at actually no, it was my second fellowship. I had a summer undergraduate research fellowship also. I talk more about this on my website. So I know a little bit about SQL and database and computer science because I wanted to do this minor, but I didn't finish the project management capstone project because I realized I was starting to burn out. And ever since I was young, my family and teachers tried to help me not burn out. But when I was doing PhD, I felt obligated to finish because people were paying me, and finish early because it's taxpayer money paying for these fellowships. Okay, so Professor Baron offered me the fellowship, but it had to be in manufacturing engineering. But I focus in health systems engineering because WPI doesn't have that concentration. Then my bachelor's is in industrial engineering, and ever since Professor Conrad taught me a linear programming and also integer programming class in fall of 2010, I have been studying operations research, and I believe I've progressed in a sense from that type of modeling, linear type thinking, to more dynamic type thinking, nonlinear thinking, and I consider system dynamics to be part of operations research. And yeah, you can see all the other methods I studied, very in different packages. People like making a lot of software, and I appreciate it. So right now, for my dissertation, I prefer to focus on dynamic computer simulation methods. And I'll talk about that more later. Yeah. So originally I was in manufacturing engineering, like I said. We had a very aggressive deadline. I tried to do master's and PhD in 4.5 to 5 years. And that's insane. And like I said, I didn't say that Professor Conrad was my advisor. But yeah, I have been working with her ever since I was a junior at WPI, doing research with her and other professors in industrial engineering. And she and other professors suggested I go to the system dynamics CLMs, the collective learning meetings, and talk to Professor Redziki, Saeed, Pavlov, so I could learn system dynamics because they believed in me and my ability to build complex models, and I appreciate it. And so recently I decided to switch departments because I'm not truly manufacturing engineering, and it's a, what's it called, a misnomer? False name. I actually am more interdisciplinary, and I will hopefully do this project, mix of social work, system dynamics, operations research, even though I consider system dynamics to be part of operations research, but we should keep the name in there so people are aware of what I like to study and hiring purposes. And I will hopefully have co-advisors, Professor Conrad and Professor Redziki. Professor Conrad knows discrete event simulation. She's the one who teaches it at WPI. And she also knows optimization methods. And Professor Redziki, expert system dynamicist. Oh yeah, a crazy person. Yeah, I'm really crazy sometimes. I don't know if that's due to the lack of sleep or not. So in my dissertation, the first attempt and this second attempt, I focus in analytical methods, and people like to call this data science now because you focus everything on data from the beginning, querying, database, blah, 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 whatever. Oh, and I forgot to say, this is a very informal meeting. I'm just chatting with people so they understand what I like, and so we can have better conversations in the future. And feel free to chime in at any time and let me know if I'm talking too much. So data. We consider data to be anything: text, numbers, numerical, quantitative, qualitative. Data science is simulation science part of data science? Is computer science part of data science? I'm so confused. All these names for things. For me, it's just analytics. There's statistics, there's operations, or actually maybe I consider statistics to be part of operations research. I don't know. To me, operations research is an umbrella term for using different modeling methods to understand operations and systems. I don't see the big difference in operations and systems. Yeah. So because I'm interested in operations, I care about people, I care about data collection, blah, 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 all that stuff. So my question to you is, do you consider computer science, simulation science to be data science? Data science to be part of other things? I have no idea. Or just let the scientists care about this, because I truly believe I'm more engineering focused. And the question, given the problem, what method should we use, has been driving me crazy, because I like to really narrow down and then finish something so I can move on. And that is something a lot of people have suggested to me, because I have trouble moving on, because when given a challenge like this type of question, I'll just obsess over it until I think I solved it. And that also has to do with my inexperience, I guess, because I'm somewhat young. It's all relative. And yeah, Professor Sisson, Professor Conrad, others have said I need to focus more, but this question probably will never be answered completely, but we try. It's science, and we care about the scientific method and ways into the systematic ways to answer what is unknown about the world. So, data science, analytics, whatever you want to call it, and just categorize things in 3 different ways. And I think most others also categorize analytics in 3 different ways: descriptive, past type stuff, predictive, using past data, building support vector machines, whatever, clustering, or clustering's descriptive, but also no matter, it's like a mix of both to me, in order to help people figure out things. Predict point estimates. Should we buy something, yes or no, stock market, whatever. But I focus in health, so I think about radiology, but I don't focus in radiology, I focus in mental health, which is hilarious that I burned out and have mental health problems, but that's life. Yeah, things happen. We try to move on. Professor Sisson gave me that advice the last time I talked to him. And I actually like prescriptive analytics the most, optimization models, because Professor Conrad's class and her discrete event simulation class, these and agent-based modeling, which Professor Radzicki teaches at WPI, and system dynamics, the first class I took was actually Jim Linus and Jim Hines lectures, and Professor Pavlov graded the assignments. But I relearned system dynamics a couple of times because I have a bad memory and I need to relearn things. And I relearned it with Professor Radzicki, and I need to review Professor Saeed's work class and do the work, get to work, as Professor Saeed said in the first lecture to us. So I like prescriptive, telling people what to do. I really like telling people what to do, and I wish they would listen to me more, but oh well, people have their own opinions. And I can be wrong too. And if I am wrong, I'm not so stubborn that I will argue my point until they submit usually I will think and, yeah, you're right, okay, move on. So some examples of optimization, like I said before, kidney matching, resident matching, famous problems, famous solutions, or potential solutions, I should say. We can always improve. Continuous improvement is very important in life, in my opinion, scientific progress, and in industrial engineering. So simulation science, this term is what Professor Redzicki used. I believe Professor Osgood, Nate Osgood at University of Saskatchewan, he uses, was it system science? And I just say dynamic computer simulation modeling. That's more clear to me. And so in my worldview, there are just three types, or not just three types, but three types I prefer to focus on. Discrete event simulation, which is the first one I learned, system dynamics, then agent-based modeling. That's in order of the classes, the introductory courses I've taken. And I have not built a large or even my own small scale system dynamics problem yet, but I'm currently trying to. And I built a small agent-based model in Professor Redzicki's classes because at WPI, and because of the type of methods we study, it's important to always be modeling. And there are other types of simulation methods that I don't really focus on, but you can read about. And also people teach this at WPI and other universities, but I prefer the big three. Oh, I also gave, in the presentation I uploaded has all my notes. So sometimes I mention things that I didn't add in the notes, and sometimes there are a lot of other materials and resources in my notes because I just write whatever comes to my mind, whatever I feel like. So discrete event simulation, for those who are not aware of what that is, a lot of people call it process modeling. So you can think about it as you go into a restaurant or anything in the hospital, the emergency department, and we are modeling different processes within just that department and how long it'll take for someone to be seen and different resources that that specific person will utilize. So it's all about utilization and wait times and things like that. And there are a lot of other details, but I am afraid that I'll run out of time, so I will defer to others, and you can message me personally if you'd like to talk about what discrete event simulation is. And there are a lot of similarities between the three methods, and that's why I am interested in multi-method modeling. So, this is a picture. I like the pictures from the Big Book of Simulation by, I forgot, Andrei Borshev, is that it? Yeah, that's his name, the creator of AnyLogic. Their visuals are beautiful. But I learned discrete event simulation using Rockwell Arena. It's very process-oriented. You think of the individual going through a system or subset of a system. And system dynamics. That's what I'm currently studying, and for me, it's actually the hardest of the big three. It's a very interesting way of thinking of the world because I'm more used to linear type thinking. And the basis of this to me is differential equations, control theory applied to social systems, whatever you want to call it. But the very basic is calculus. And okay, stop diverging. I keep thinking about other types of modeling, like what is derived from algebra, the matrix algebra, linear programming types. Okay, focus. So now, as most of you know, because this is the System Dynamics Club, stocks, flows, and feedback loops, rates, different names for different things. I hope I was clear in my slides about what these different things mean. And there are a lot of parallels in other simulation methods that I might talk about at a later time or in my paper that I will talk about soon. And agent-based modeling, which is also very individual, like discrete event simulation. That's why I actually believe that agent-based modeling and discrete event simulation are more easily, well, not I believe, it's true. It's easier to combine those two methods compared to system dynamics. Or maybe I shouldn't say it is true, I believe, whatever. So most of what Professor Redzicki taught me and what I've learned about agent-based modeling, there are a lot of rules and for agent behavior, and the combination of these agents interacting with each other and their environment produces emergence, and that's how we get phenomena like infectious disease. And I'll talk about the discrete versus continuous time in quotations in the next slide. Oh no, not this slide, another slide. I made this a couple of days ago and then I forgot. So within simulation science and dynamic modeling, there are three big types, and I actually consider dynamical systems, to be the same thing as system dynamics, because I just look at the very core differential equation, but others disagree. And you can do a lot of different types of levels of abstraction. My thoughts aren't clear on this. Sorry. As you can see, you can model different strategic levels and macro level, build different types of models depending on what method you know and what your problem is. And Professor Pavlov actually mentioned this to me years ago about how, given a problem, why don't we just throw every single type of model and look at it from different perspectives, like what most people are doing in data science now. And that actually makes sense. We can try, but these models may produce different results. And we actually should consider the system more and how different subsets of the system will affect the larger system. And that's why I believe everybody should be studying systems thinking or system dynamics and be systems citizens, as what I think Barry Richmond coined that term. I'm currently reading a book about him right now. So before I talked about discrete or continuous time within each simulation method, and from what I see, discrete event simulations, in the name, it's discrete. The core of system dynamics is continuous. In agent-based modeling, in NetLogo that Professor Redzicki taught, it seems to be discrete. You're going through ticks, different time, and you're updating it in each tick. But in any logic, it seems to be continuous in quotation marks, because it's not truly continuous, because we're using a computer and they take, in order for computers to calculate, they approximate this continuous continuity. And when I talk about space, I'm talking about spatial aspects that people use in their models. Agent-based modeling, especially pedestrian flow type models and disaster relief, traffic simulations. Yes, spatial awareness is very important. And in discrete event simulation of a clinic, a process in a clinic, and other types of processes, yes, you can just put a CAD drawing in there. System dynamics, not really, but you can because of software nowadays. Well, I should say it depends on what type of model you're building. And the basis, as I said before, differential equations for system dynamics, agent-based modeling seems to be artificial intelligence, and discrete event simulation modeling is queuing theory, which is mathematics. All of this is just math to me, applied math. And when I say computationally, how expensive things are, I'm borrowing the term from operations researchers and others, big O notation, which I don't truly remember. It's been a while since I studied algorithms and such, but for large problems, agent-based modeling, discrete event simulation takes a very long time to run. And my model that I built with my teammates and for my senior project took hours to run. And then we have to analyze the data that the model outputted, because you're modeling individuals and you're keeping track of all these. And in system dynamics, you can do that through subscripts. But the very core of system dynamics, using differential equations, that's actually pretty fast to model. But system dynamics models are difficult time-wise to build. So you have trade-offs. And this is a figure from Professor Radzicki's working document, WPI Center for Simulation and Data Science. And he and others here, people around the world, are trying to figure out what methods should we tell people to use, because policymakers, doctors, they have other things to think about, taking care of people directly. Everybody has to do that. You have to take care of yourself, your family, your friends. And we don't have the time. Time constraints are the hardest thing in life. And we want to produce some document in order to guide people. Let them know this is what we think you should use, and talk to this person, talk to that person. Consultants. So in the paper I started to write with I already wrote a lot of it. I submitted to simulation actually and got mixed reviews. So I talk about linear thinking, how simulation modeling and data science can be used in series or in parallel. And in all modeling methods, we care about the inputs, parameters, constants, whatever you want to call it, into our model. So we have to figure out what to use. But it also depends. Sometimes those parameters are not that important, or they have different sensitivities. And of course, we want to consider the output analysis from the output and analyze that output from our simulation models, sensitivity analyses, confidence building. So people will listen to us. And modeling is a very iterative process. The figure on the left, data science, simulation science, I just keep going round and round when I look at this. We can get stuck in a loop where we are paralyzed by analyzing things. What's it called? Paralysis by analysis. And we need to help each other or help ourselves by creating boundaries. And Professor Conrad helped me with this paper because she could tell that I was going insane about how to stop, because I can do this for the rest of my life, and I probably will. But for a paper, in order to submit to a journal, she gave me a time constraint, and I didn't get to talk about and address. Oh, hello? Address yes?
Sorry to interrupt. There is a comment in the comment section if you want us to read something for you, if you want to answer.
Sure.
This is from Kareem. He says, I don't agree with the diagram. Abstraction and details are confounded in the y-axis. You can have low abstraction and high detail, which is where I would place DAS. Thank you, Kareem.
I'm not sure. I have to think about that more. And I'm not very good verbally, so I will address that after the presentation in a couple of days, because I have family visiting, so I need to spend time with them because they are flying back on Sunday. Okay, so thank you. Hope to address that later. And now I keep thinking about it. Okay. So I'm looking at the time, and I didn't know how long it'll take to talk about this, but if you would like to look at the paper, I believe I can send it to you. Professor Redzicki, he is very open to these type of things, I believe, and Professor Conrad and we're slightly concerned if someone will plagiarize, but we're such a small community, I believe everybody would know. And I've been working on this problem for a while. I actually don't believe I am qualified to write this type of paper, but I'm trying. I believe Professor Osgood, Nate Osgood, and the other titans in the field should be writing this in a book chapter, or it could be a whole book on it by itself. But I like to help facilitate conversations. And yeah, so I want to talk more about meta models in data farming, but I need to review and read more about these types of modeling. And I actually talked about maybe including this in my paper when I presented this presentation in 2015 to the System Dynamics Club in our weekly collective learning meetings. But then due to time constraints and working at the VA, I didn't get around to researching more about data farming meta models. But you have access to these slides. And I also am interested in axiomatic design, how to design good models. And Professor Chris Brown is the expert in that. He uses it for skiing, other manufacturing type stuff. And this method, axiomatic design, is like trying not to do too many things with one model. Building smaller models and connecting them is better design. And some other work that I'm currently thinking about and should work on is this opioid individual model, which I've somewhat been scooped because a professor who builds dynamical systems models already published, but he doesn't have an economic component. I learned about that last week. And I'm just helping with System Dynamics Club until someone else can take over. So are there any other questions? Or can I move on to my qualitative journey and my recommendations and how I solve my problems and other people help solve my problems? Okay. So what I have learned throughout this process, professors have been very helpful. My fellow colleagues have been very helpful. And I focus in health, so people in health truly care about others and are not everybody, I shouldn't, that depends on the person, depends on their circumstances, how tired they are in their training. And I really appreciate everybody who has helped me throughout my life. So help others, help everyone. That's what I truly care about. That's my mission in life. Somewhat impossible because you can't help everyone. You need to help yourself first. And we should help the system and individuals, but helping the system is hopefully is more effective. I want to heal the world. Yeah, I like listening to music to help me relax and distract myself from the sadness in life. So I suggested a lot of different songs, and I have a playlist for this presentation that you can listen to if you'd like. Yeah, and I care about being lean a lot because my parents are actually Vietnamese refugees, and they came over here with nothing. And I actually don't like to talk too much about this because it makes me very sad and makes me think of war, which makes me very sad. But yeah, they didn't have much and taught me to be lean and to help people because people helped them when they came over here and save money, which I'm not doing a very good job of right now, actually. But I like going to conferences and seeing my friends and family. Trade-offs. So I have a lot of problems. Everybody does. I'm actually very engineering, operational focused. And like I said before, this question is driving me nuts. I've never given it much thought. I just like learning different methods and applying it. But then Professor Radzicki changed my life. Like a lot of other people changed my life, but in a good way. I think I'm crazy in a good way, hopefully. Like I said, Professor Conrad gave me a time constraint. And by presenting, I got a lot of feedback from people in academia, winter simulation. Getting distracted. So I presented in System Dynamics Club. And when I go to winter simulation, I've only been to 2. I would talk to others, like Professor Osgood, who is very kind. And he and I would talk about different methods and what type of models are important, what we should focus on. I keep diverging. I have so much trouble focusing. And people remind me of that, and I appreciate it because we need others to help us in life. And I borrowed these terms, converging and diverging, from Rafet and Saeed's PhD journey model, which I'm very excited to look at in the future. I don't know if you're currently working on that model right now because they're both very busy with organizational behavior, and Saeed currently working on water resource models, which trying to save the world. I love it. Okay, and I have this other problem where I am easily saddened by these wicked problems that we were trying to solve. Before, I went to the VA to work at White River Junction VA Medical Center. For those who aren't aware, that's Veterans Affairs. I was working on a project about PTSD with them. I have been working on mental health models with them since my junior year, somewhere between my junior and senior year of undergrad. And I used to be fine. And then somehow I developed more empathy. And that's actually not a bad thing, but too much empathy can paralyze you from doing something. And I care a lot about predicting, well, maybe I shouldn't say versus, but predict and prescribe and doing. I need to write that down, not versus, but and. Sometimes I fall into the either or trap. It's not exclusive or, you can do all of them. And so in order to fix this, I have friends. Yes, I have friends. I like to have fun and help people. I am part of a lot of different organizations and have been since I was young. I like to be well-rounded and hope others have the opportunity to have fun, go to social events, play sports, do what makes you happy. Because this life is pretty sad. Or it can be very happy. There are different perspectives. But then helping others make me think of their problems, and then I go into this vicious cycle again. Reinforcing. So my solution is try to stay away from people who have too many problems. But it's hard to stay away. But we need to protect ourselves first before we can help others. Help yourself before you help others. Serve yourself and serve others when you can. And my other problem is I keep thinking about this quote, all models are wrong, but some are useful. And we can help others in different ways. And I think I actually like helping people directly more. So I'm thinking about teaching kids. And I spent a lot of last year with my cousin's son, who was at age 2. Some doctors and others diagnosed him with autism. So that's why I'm very interested in autism research, special needs research at the moment. And I think I want to study social work and simultaneously do research in order to help people. And I like to help the helpers by helping WPI system dynamics, the society, and others. Because right now I'm doing social media and I read a lot, so I just disseminate information, but it might be information overload. I'm on Twitter and I've been tweeting about every single, well, not every single, but a lot of different articles from Inform, SIAM, Society of Industrial and Applied Mathematics. Informs is Operations Research Management Science. SIAM is actually under the Informs umbrella, and so is the Institute of Industrial and Systems Engineers. Yeah. And more songs, more inspirational quotes. So my main focus in life is try to be happy again. Spend time with friends, family, do what I love, and I really do enjoy mathematics and simulation modeling. Some people think it's weird, but I don't care. I just laugh at them and say, what do you do for fun? I like to try to solve problems. But you can solve your own problems by having fun and watching cartoons, whatever you like, playing video games. It's fun too. I do that. But not as much anymore because operations research is my favorite hobby. And you need to learn that people don't always do what we want. We can suggest things. I forgot, there was some paper that said maybe 20%, less than 20% of simulation models we build, I think they were mainly looking at discrete event simulation, that the decision makers actually use what we suggest. I'm actually not even sure if the VA used the model that I and my teammates built. I should ask them. because my PhD, the first attempt, the Dr. Brian Shiner and Dr. Vince Watts, they were my senior year project, the discrete event simulation model and other analytics. They sponsored both projects, but we are all very busy trying to put out fires to talk. Yeah, focus on children. Yes, I know I need to talk to Peter Hoffman and need to exercise more, be one with nature, especially because I have back problems and I'm lazy. If I don't have someone to exercise with, I need to be more disciplined. And I used to be more disciplined. I used to go to Catholic school, actually. Spent 12 years in 2 different Catholic schools. And I am going back to that now, to studying more about religion, spirituality, and math is a religion to me. I'm just joking about that, but I do like to study these different things in order to make sense of the world. And I hope I can do that and find peace, and I hope you can too. And that's the end of my presentation. Are there any questions?
Hello, Christine.
Hello?
Can you hear me?
Not very clearly, but hold on, I want to see the chat.
Thank you, Christine.
Where are we? I hid it, so I don't want to hide it, so it's fine. Hello. Okay. Yes? Hello?
I heard someone else.
Oh,
Right,
I didn't make stats.
All right.
Hi.
This is Daniel. I'm new friend of the WPI System Dynamics Club. And I was taking notes as you were talking, and there's a lot there. I think your main question about, given a problem, what method to use, has sort of a philosophical trap built into it, because the method you use can alter your problem, and then it might suggest a different method. So you can easily fall into infinite regress. Infinite. Yeah, regress. So you can keep using a method, solving a problem, creating another one, using a different method, solving the problem, creating another one, and so on, and you'll never really answer the question.
Yeah, the paralysis by analysis.
Sort of, yeah,
in a sense.
phenomenon. Yeah.
Interesting. Thank you for your observation.
And let's see. I think you mentioned that there was some burnout. I think burnout is an experience most graduate students have at some point. And I mean, I certainly experienced it at one point, and I found a very sort of helpful guide to it that indicated that it was sort of misplaced expectations in combination with a role ambiguity. Like you didn't know what authority you had to act and what was expected of you other than your own expectations for you, and they were out of line, and so you can never quite meet either your expectations or someone else's expectations, and so that constant sense of failure sort of leads to it's a feedback cycle, essentially. So I think thinking about it that way might help address it, because then you have strategies like getting help to define what role you have in whatever organization you're working in.
Okay, thank you.
And I have many more notes, but I suppose I can email you or something if we want to discuss this further.
Okay, thank you. And I realize we're at the top of the hour. It's actually 10:01, so I don't know if anybody has more questions. I ended up talking a lot more than I expected because I tend to get off track. Focus, converge, follow the slides. That's why I make slides. Then I skip around because I don't know, that's just how my brain works. I'm nervous. So are there any other pressing questions, or we can take this offline? Please feel free to email me, and maybe
Maybe
even
real quick here, Christine. I will try to make it short. This is Solomon. Thank you very much for your presentation. I had the same thought like Daniel. Do you also identify some patterns, beside those mentioned by Daniel in your journey? And if so, have you considered, like Jack Homer did in his worker burnout model, to build either system thinking or system dynamics model on that? And the second is just a comment, at the end, or recommendation or suggestion. In your study list, you also mentioned religion, I don't remember the other one, math and spirituality. I would recommend, to take a look at also philosophy. I don't know if you like that or not, but there are two philosophers I like. It's Spinoza and Immanuel Kant. I think you can find a lot from there if you really like philosophy.
Oh, yes. We're trying to get PhDs, doctors of philosophy. We should study the philosophers, right? Thank you. Thank you, Suleiman. I have trouble saying your name sometimes. Okay.
Thank you, Christine. That was interesting. Scream.
Yes, I recognize your voice. Hi. Thank you. Oh, I also want to save this chat. Don't save chat, so then I can download it later, because if we don't save, the chat goes away. And
Thank you, Christine.
Thank you, everybody. I'm actually not sure who's on the call because my screen is blocked. I don't have my command center today. So I hope somebody figured out the max participants for me. And okay, thank you. I'll just get rid of this, then stop the recording so it can render.